Okay, welcome back. So I'm going to do a few examples of simplifying some radicals, this time with some variables in them. So the first one I'm going to do is the square root of 25x cubed. Okay, I'm going to simplify this, and remember that just means you want to try and move any perfect squares that are in here outside of the radical where you can kind of simplify them out, right? So first I want to think of, well, I can kind of break this into two pieces, if you will. I can write this as the square root of 25 times the square root of x cubed, and then kind of simplify each piece individually, do kind of the numbers and the variables on their own. So the square root of 25, we've already seen that that's a very nice number, and the reason for that, right, is that when 25 is 5 squared, and so the square root and the square cancel out, right? And so we just get 5. But what happens with this square root of x cubed? Well, I want to think of, are there any perfect squares living within this radical inside of this x cubed? So what you want to do is you want to think of, are there any perfect squares in there? Well, inside of x cubed, is there an x squared? Okay, and yes, there is. There's 1x squared, right, and then an x left over, right? And so why we want to do this is because the square root will cancel out with that square, and we can kind of move that x on the outside, okay? So we still got that square root and square canceled to just give us 5. And then this one right here, we can separate those two up, do the square root of x squared and the square root of x. Well, the square and the square root cancel. So I just get 5 times x times the square root of x. Or in other words, 5x times the square root of x. Okay. And that would be as simple as we can go, right? Because there's no perfect squares within x. So that's as simple as we can go. Okay? Let's do a few more like this. So let's look at the cube root of 54, x to the 6th, y to the 8th. Let's do that. So again, you may want to kind of think of splitting these up into different pieces. Just worry about 54 first. Are there any? In this case, we're doing a cube root. So we're trying to figure out, are there any perfect cubes inside of 54? Well, let's start by just factoring out 54 is even, so 2 goes in there. So we can do 2 times, let's see, that would be 27, right? And then I could think, what goes into 27? Well, 3 does, right? 27 is 3 times 9. Okay. And I can think, what goes into 9? Well, 9 has 3 and 3 in there, right? So I kind of just rewrote that 54. 54 is the same as doing 2 times 3 times 3 times 3, okay? And why did I want to do that? So that I could see a perfect cube right here. We've got 3 3s, okay? So I'm going to rewrite that first thing as 2 times 3 cubed there, okay? And then the second one, are there any perfect cubes in the x? Well, yeah, we have got x to the 6th there. So there is an x cubed in there, right? As well as one other x cubed. So there's 2 perfect cubes in there, x cubed and x cubed. And then are there any perfect cubes in y to the 8th? Well, yeah, 8 is bigger than 3, so we can do y cubed. 2 times will get us y to the 6th. So we'll have 2 left over to get to 8, right? When I add these exponents, I get 3 plus 3 is 6, plus 2 is 8, right? So I'm just kind of trying to factor out the y cubed parts because those will make things easier. Okay, so on all the parts that have a perfect cube, those will cancel out with the cube root and move out front. So we have a 3 cubed, so that can cancel out with the cube and move up front. So we're going to have a 3 out there. We've got an x cubed will cancel out, so we're going to have an x out there. An x cubed cancels out, so we're going to have an x out there. We have a y cubed and a y cubed, so we're going to have 2 y's out there. And then the stuff that's left under the cube root is that doesn't have a perfect cube on it is there's a 2 in there still from right there. And there is a y squared right there. Okay. So I could simplify this a little bit because we've got 2 x's there, so that would just be x squared. 3x squared y squared times the cube root of 2y squared. And that's as simple as we can go. Okay, so you're just, when you're simplifying a root, you try and look for any like in this case, if it's a cube root, right, you look for any perfect cubes that are in there so that you can take them out. If it was a fourth root, you'd look for any fourth powers that you can cancel out to move out front. Okay? In fact, let's do one with a fourth root real fast. One more example, and then we can have you work on some homework problems. Okay. So I'm going to do the fourth root of 81 z to the 11th power. Okay? And we want to simplify this. So we want to think of the things that go into 81, try and factor that out so that we can find any perfect fourth powers that are in there, right? So let's see, what goes into 81? Well, I know 9 and 9 do, so I could write it as 9 times 9, z to the 11th still. And then I could factor each of those 9s, right? This 9 is 3 times 3. And that 9 is 3 times 3. So we've got altogether 4 3s there, which is good because we're trying to undo a fourth power, right? And then I want to think of what perfect fourth powers are in z to the 11th. Well, you can write it as, you certainly can fit one z to the 4th in there, right? Because there's actually 11 z's there. A second z to the 4th would push us to z to the 8th, right? And then how many left do we have? From 8 to 11, we need to go up 3. So we're just missing 3 z's there, right? So I can't do any more fourth powers. I just have 3 left, okay? So we've got our z's and fourth powers, and then I can combine these 3's up into a fourth power to be able to cancel out. So we got 3 to the 4th, z to the 4th, z to the 4th, and z cubed. Okay, that's what we've got there. So anything that has a fourth power on, you can cancel it out, the fourth power with the fourth root, and move it out to the front. So we've got 3 moves out. The fourth power cancels out with the fourth root on the z. Fourth power cancels out with the fourth power on the root, and we get another z. But then this z cubed here, that doesn't have a fourth power on it, so it's going to be the fourth root of z cubed. Okay, so in total we get 3z squared times the fourth root of z cubed, and that's as simple as we can go. Okay, so now that you've seen these, you'll probably be able to do a decent amount of the homework. I'll tell you which problems will you can do. Go ahead and try those and then move on to the next video.